If you've ever looked at the world's most advanced, and let's be honest, most incredibly expensive surveillance drones, you've probably noticed something kind of funny about them. They don't look like your typical sleek, futuristic fighter jets. Actually, they look a whole lot like giant flying whales. It's a totally bizarre, disproportionate design. I mean, why on earth would engineers build a multi-million-dollar state-of-the-art aircraft that looks so, well, weird? Today, we're diving deep to decode the anatomy of these flying whales. So, the central mystery we're tackling today is pretty straightforward. What exactly is hiding inside that massive forehead? It's this glaring visual incongruity, right? It immediately grabs your attention because it seems entirely out of place on a high-speed aerodynamic machine. But as we know with high-tech, extremely costly surveillance tech, form always follows function. That gigantic hump is heavily engineered, and figuring out what's actually inside completely flips how we understand these machines. We're talking specifically about two absolute marvels of military engineering here, the Air Force's RQ-4 Global Hawk and the Navy's MQ-4C Triton. Both of these share that signature giant flying whale look. Picture it. On one hand, you have these incredibly long, elegant glider-like wings that are built for maximum endurance in the air. But then, bam, right up front, jarringly, you have this massive, bulbous hump sitting there, completely out of proportion to those graceful wings. It really begs the question, what could its purpose possibly be?
Well, let's play a quick game of elimination to figure it out. Normally, a big bulge at the front of a traditional aircraft houses the cockpit, right? But these are unmanned systems, so no pilots up there. Scratch that. You might then guess, okay, maybe it's packed with ground-penetrating radar. Actually, that's incorrect too. The intelligence sensors they use to scan the Earth, those are mounted underneath the belly of the aircraft. So, if it's not holding a human and it's not looking down at the ground, what exactly is it doing up there?
The answer actually comes down to a single number, 4. That massive forehead is hiding a massive 4-foot-wide parabolic satellite communications dish. Yep, imagine a dish literally 4 feet across, securely housed right inside the nose of the aircraft. That is exactly what gives the drone its signature whale-like hump. It simply needs that much physical space to contain this giant piece of hardware.
And this highlights a huge difference between low-cost drones and these incredibly costly platforms. Low-cost tactical drones, they're relatively cheap because they only fly short distances. They just use basic line-of-sight radio to talk to operators on the ground. But these flying whales, these are high-value strategic assets. They fly grueling missions lasting over 30 hours, traveling thousands and thousands of miles away from their home base. When you're flying that far over the horizon, basic ground radios are completely useless. You absolutely have to rely on deep space satellite communications just to stay connected.
And keep in mind, they aren't just sending, simple text pings or a little location blip. No way. The system is designed to stream gigabytes of high-definition surveillance data back to analysts in near real time. Think about it. While a cheap, low-cost drone might send back a super grainy local video feed, these premium platforms are gathering massive volumes of continuous, high-def video and radar imagery. All of those gigabytes have to be routed straight up through that giant 4-foot dish to a satellite, and then beamed back to human analysts all over the globe. That immense, non-stop flow of heavy data, it literally requires an enormous dish.
But hold on, because that brings us to an even more impressive engineering feat. You might be picturing this large dish just bolted firmly inside the hump, pointing straight up at the sky, right? Well, that is the real trick here. That giant dish isn't static. It's actually a highly dynamic, fully steerable piece of robotics that physically moves around inside that bulbous forehead.
To understand why it absolutely needs to move, you have to consider the extreme environment it operates in. 60,000 feet up. At that incredible altitude, the aircraft isn't just gliding peacefully along. It is getting absolutely battered by heavy winds and navigating some seriously intense atmospheric conditions. The drone itself is constantly shifting, tipping, and adjusting just to stay in the air.
So let's break down how this mechanical process works in real time. Step 1. As the drone banks to make a turn or fights against those punishing heavy winds at 60,000 feet, the aircraft's body is moving wildly relative to space. Step 2. To compensate for all that turbulence, the giant 4-foot antenna inside the hump mechanically rotates and pivots. It literally senses the movement of the drone and moves in the exact opposite direction. And then step 3. Because it can steer itself instantly, it maintains a flawless, laser-focused lock on the communications satellites high above. It's wild to think about. Even while the drone is getting thrown around by the wind, the dish inside the hump is doing this perfect dance to keep gigabytes of data flowing without a single drop.
It really makes you pause, doesn't it? What just looks like a weird bulbous hump on a giant flying whale is actually housing a massive, continuously pivoting robotic dish, fighting the elements just to beam gigabytes of data down from the stratosphere. It perfectly highlights that massive gap between cheap everyday drones and these highly costly state-of-the-art military assets. Which leaves us with this incredible question to think about. What other extreme, invisible engineering is happening miles above our heads right now? Thanks for joining us for this explainer, and we'll catch you in the next one.